君の虜になってしまえばきっとこの夏は充実するのもっともう戻れなくたって忘れないで
Now let's go on with our introduction. Under this, we have the application. So the uses we make of water in lakes, rivers, and ponds, and also in the streams, is greatly influenced by the quality of water found in them. In many parts of the world, the introduction of pollutants from human activity has seriously degraded the water quality. Water quality management is concerned with the control of pollution from human activities so that the water is not degraded to the point that it is no longer sustainable for intended uses. To know how much waste can be tolerated, or the technical term is assimilated, by the water body, you must first know the type of pollutant discharge and the manner in which they affect water quality. You must also know how the water quality is affected by natural factors such as the mineral heritage of the watershed and the geometry of the terrain and the climate of a certain region. Originally, the intent of water quality management was to protect the intended uses of water body while using it as an economic means of waste disposal within the constraint of its assimilative capacity. By understanding the impact of the pollutants on the water quality, the environmental engineer can properly design a treatment facilities that can remove those pollutants to an acceptable level. Application. We have the quantitative and the qualitative. So let's start with the qualitative application. The qualitative discussion of pollutants and their sources provide a basis for developing management strategies to control pollution before it enters the surface or the groundwater. Quantitative application. The quantitative discussion provides a method for evaluating the strength of a wastewater, estimating the maximum amount of pollutants that a body of water can receive and still meet water quality standards, and estimating the pumping rate that will minimize salt water intrusion into a well. Now you can see the major categories and principal sources of pollutants. For the pollutant category, we have oxygen demanding material, nutrients, pathogens, suspended solids and sediments, salts, toxic metals, toxic organic chemicals, endocrine disrupting chemicals, pharmaceuticals, and personal care products, as well as heat. You can also see here are different principal sources of pollutants, namely point source and non-point source. Under point source, we have domestic sewage and industrial wastes. And under non-point source, we have agricultural runoff and urban runoff. As you can see on the data, oxygen demanding material, nutrients, pathogens, suspended solid, and sediments comes from all of our sources, from domestic sewage, industrial waste, agricultural runoff, and urban runoff. While salt comes from only three sources: industrial waste, agricultural runoff, and urban runoff. Our toxic metals comes from two sources, which are the industrial waste and urban runoff. Our toxic organic chemicals comes from also two sources, the industrial waste and the agricultural runoff. For the endocrine disrupting chemicals, it comes from three sources, as well as the pharmaceuticals. Comes from domestic sewage, industrial waste, and agricultural runoff. Where the personal care product comes from domestic sewage alone. And for the heat, the last one, it comes from industrial waste. So later on, I will discuss what is point source and non-point source, as well as all the categories or major categories of pollutants. Point source. Domestic and industrial waste are called point source because they are generally collected by a network of pipes or channels and conveyed to a single point of discharge into the receiving water. When we say domestic sewage, it includes water coming from homes, schools, and office buildings. Municipal sewage is also a domestic sewage into which industrial waste are also discharged. Non-point source. Urban and agricultural runoff are characterized by multiple discharge points. These are called non-point sources. Often, the polluted water flows over the surface of the land or along natural drainage channel to the nearest water body. Even when urban or agricultural runoff water are collected in pipes or channels, they are generally transported the shortest possible distance for discharge so that wastewater treatment in each outlet is not economically feasible. Much of non-point source pollution occurs during the rainstorms or spring snowmelt, resulting in large flow rates that makes treatment even more difficult. Now, we're here to discuss major pollutant categories. So let's start this with the oxygen-demanding materials. Oxygen-demanding materials is anything that can be oxidized in the receiving water with the consumption of dissolved molecular oxygen. The consumption of dissolved oxygen, DO, poses a threat to fish and other higher forms of aquatic life that must have oxygen to live. The critical level of DO varies greatly among species. Oxygen-demanding material in domestic sewage come primarily from human waste and food residue. Partially noteworthy among the many industries that produce oxygen-demanding waste are the food processing and the paper industry. Almost any naturally occurring organic matter, such as animal dropping, crop residues, or leaves that can get into water from non-point sources, contribute to the depletion of the DO. Nutrients. Nitrogen and phosphorus, two nutrients of primary concern, are considered pollutants because they're too much of a good thing. Problem arises when the nutrient level becomes excessive and the food web is grossly disturbed, which cause some organisms to proliferate at the expense of others. As will be discussed in later section, excessive nutrients often lead to large growth of algae, which in turn become oxygen-demanding material when they die and settle to the bottom. Some major sources of nutrients are phosphorus-based, detergent, fertilizer, and food processing waste. Pathogenic organism. Microorganisms found in wastewater include bacteria, viruses, and protozoa exerted by diseased persons or animals. When discharged into the surface water, they make the water unfit to drinking, that is, non-potable. Suspended solids. Suspended solids are organic and inorganic particles that are carried by the wastewater into the receiving water. When the speed of the water is reduced by flowing into a pool or a lake, many of these particles settle to the bottom as sediments. Turbidity, caused by colloidal particles that do not settle readily. The usefulness of the water is reduced as the excessive sediment loads are deposited into lakes and reservoirs. Even in rapidly moving mountain streams, sediments from mining and logging operation has destroyed many living places, also known as ecological habitat for aquatic organisms. Salts. All water contains some salt. These salts are often measured by evaporation for filtered water sample. Total dissolved solid, or can be called as TDS, salt and other things that don't evaporate. A problem arises when the salt concentration in normal fresh water increases to the point where the natural population of plants and animals is threatened or the water is no longer useful for public
water supply or irrigation. High concentration of salt are discharged by first, many industries. Second is the use of salt on roads during the winter caused by high salt level in urban runoff, especially during the spring snowmelt. In addition, evapotranspiration causes salt to be further concentrated, which cause crop damage and soil poisoning. Pharmaceutical and personal care product, also known as the PPCPS. These are class of compounds that are applied externally or indigested by humans, pets, and other domesticated animals, which are released to the environment through the disposal of expired, unwanted, or excess medication to the sewage system by individual pharmacies or physicians, and also by metabolic excretion or wash into wastewater during bathing or washing. Finished water waste is less than 10 mg per liter, and raw wastewater is greater than 100 mg per liter. Examples of pharmaceuticals are common prescription and veterinary drugs. Endocrine disrupting chemicals, or also can be called as EDC, alters the normal psychological function of the endocrine system and can affect the synthesis of hormones. Naturally occurring EDS, such as 17-beta estradiol, are both naturally occurring and synthetic estrogen, used as method of birth control and excreted into the wastewater. EDC can mimic estrogen and androgen or thyroid hormones or their antagonists, although the structure of many EDCs bears little resemblance to that of natural hormones with which they interfere. They can also interfere the regulation of reproductive and developmental processes in mammals, birds, reptiles, and fish. The chemicals can also alter the normal psychological function of the endocrine system and can affect the synthesis of hormones in the body. EDC can also target tissues where the hormone exert their effect. Pesticides. Major classes of pesticides are herbicides, insecticides, and fungicides. When we say herbicides, these are used to kill weeds, and most commonly used herbicides are atrazine and metolachlor and alkachlor. And for the insecticides, it's used to kill insects. Typical insecticides are chlorophyrophos and diazonos. For the fungicide, common fungicide are sulfur and chlorothalonil and mancozeb. In studies conducted by U.S. Geological Survey, it was found that 90% of water and fish samples from all streams contained one or more, often several pesticides. And in water, pesticides are currently used was found. And also 50% of the well sampled contained one or more pesticides. And higher detection frequency shallow groundwater found beneath agricultural and urban areas. Lowest detection frequency are in the deeper aquifers. Heat. Those in electrical power industry are well aware of the problem of disposing of waste heat. Water released by many industrial processes are much hotter than the receiving water. The benefit of this is the production of clams and oyster be increased in some areas, while the negative impact of this is many important commercial and game fish will decrease, such as salmon and trout. It will also increase the rate of oxygen depletion.